Hey everyone, I hope you're doing well today. This video is meant to be a review on numerical and algebraic expressions. I'll be going over 30 different problems broken down into 7 different parts. Pause to check out the timestamps and feel free to jump around the video by using them in the description. This video is meant to serve as a review, assuming that you've learned about numerical and algebraic expressions in pre-algebra. I encourage you to pause the video whenever you need to think, grab some paper and something to write with, and let's do some math together. In part 1, we're going to practice evaluating numerical expressions. Here's number 1. We have 14 plus 3 times the quantity of 5 plus 3. Following the order of operations, grouping symbols must go first, so we're going to add this 5 plus 3. 5 plus 3 is equal to 8, so we'll write 14 plus 3 times 8. Between addition and multiplication, multiplication is more important, and since 3 times 8 is 24, we'll write 14 plus 24. Finally, adding 14 and 24 together, we get a final answer of 38. That's the value of this numerical expression. Let's try number 2 here. We have 16 minus 3 times 3 plus 2 to the third power, or 2 cubed. Out of all these operations, we have to do the exponent first. 2 to the third power is really 2 times 2 times 2, and we know 2 times 2 is equal to 4, and 4 times 2 is equal to 8. Since 2 cubed is equal to 8, we can write 16 minus 3 times 3 plus 8. Between these 3 operations, multiplication gets to go next, and 3 times 3 is equal to 9, so we'll have 16 minus 9 plus 8. Remember that addition and subtraction are equally important, so we just go from left to right. 16 minus 9 here is equal to 7, so we'll have 7 plus 8. And finally, 7 plus 8 is just equal to 15. 15 is the value of this numerical expression. Here's number 3. We have 6 plus the quantity of 5 minus 2 to the third power, plus 2 times the quantity of 19 minus 16. Right away, notice that we actually have 2 sets of grouping symbols. We have the braces over here, and we have parentheses over here. Whenever we have multiple grouping symbols, we always work our way from the inside out. We'll start with this 19 minus 16, and that's equal to 3. So we'll have 6 plus the quantity of 5 minus 2 cubed plus 2 times 3. Still looking inside these braces, we need to solve this exponent of 2 cubed. From the last problem, we already knew that 2 cubed is equal to 8, so we can write 6 plus the quantity of 5 minus 8 plus 2 times 3. Still inside the grouping symbol, we need to do the multiplication next. 2 times 3 is equal to 6, so we'll have 6 plus the quantity of 5 minus 8 plus 6. Addition and subtraction are equally important, so we'll go from left to right. And while you might not know how to work with negatives yet, if you know 8 minus 5 is equal to positive 3, then 5 minus 8 is equal to negative 3. Here we'll write 6 plus the quantity of negative 3 plus 6. While adding a negative and a positive number can be confusing, you can just think of this negative 3 plus 6 as just positive 6 minus 3. That'll equal positive 3. So we can write 6 plus 3. And finally, adding the 6 and 3 together, we get a final answer of 9. That's the value of this numerical expression. Now for number 4. We have 37 minus 3 cubed over 18 divided by 9 plus 1. Whenever we see a fraction bar, remember that the numerator gets grouped together and the denominator gets grouped together. This fraction bar separates the numerator and denominator into different groups and also represents division. From this, we can rewrite the problem as the quantity of 37 minus 3 cubed divided by the quantity of 18 divided by 9 plus 1. When you have separate grouping symbols, you can choose to do the most important thing in each set. In the left set of parentheses, this exponent's the most important thing, so that'll go first. 3 to the third power is really just 3 times 3 times 3, and we know 3 times 3 is 9, and 9 times 3 is equal to 27. Since 3 to the third power is equal to 27, we're going to write 37 minus 27. For our right set of parentheses, the division's more important than addition. 18 divided by 9 is equal to 2, so we'll have 2 plus 1. Don't forget we have a division sign between these 2 sets of parentheses. On the left here, 37 minus 27 is equal to 10, and on the right side, 2 plus 1 is equal to 3. Our numerator is equal to 10, and our denominator is equal to 3. For our final answer, we're going to divide 10 by 3. 10 divided by 3 is equal to 10 thirds, or you could write 3 and 1/3. This is the value of this numerical expression. Here's number 5. We have 48 minus 4 plus 6 over 18 plus 2 cubed minus 1. The top gets grouped and the bottom gets grouped. And this fraction bar also means division. Rewritten from left to right, we have the quantity of 48 minus 4 plus 6 divided by the quantity of 18 plus 2 cubed minus 1. In the left set of parentheses, we'll do the 48 minus 4 first. And since 48 minus 4 is 44, we'll have the quantity of 44 plus 6. And for the parentheses on the right, we're going to solve the exponent first. 2 cubed is equal to 8, so we'll have the quantity of 18 plus 8 minus 1. Don't forget, we still have a division between these. 44 plus 6 is equal to 50 on the left, and on the right, we're going to have to add 18 plus 8, and we'll get 26 minus 1. Bring this division sign down, and subtracting 26 minus 1 to get 25, we'll have 50 divided by 25. Dividing these two numbers, we're going to get a final answer of 2. This is the value of this numerical expression. In part 2, we're going to practice evaluating algebraic expressions. In each of the following problems, a will be equal to 3, b will equal 5, c will equal 1/2, d will equal 2/3, e will equal 4.5, and f will equal 0.3. Here's number 6. We have the algebraic expression 5a squared plus 4bc. Remember, this means 5 times a squared plus 4 times b times c. Our first step is going to be substituting our values in for a, b, and c. Since a is equal to 3, we'll have 5 times 3 to the second power, plus 4 times b, which is equal to 5, times c, which is equal to 1/2. Now that we've substituted in our values, we just have to solve this like an order of operations problem. Out of each of these operations, the exponent will go first here. 3 to the second power, or 3 squared, is equal to 9, so we'll have 5 times 9 plus 4 times 5 times 1/2. While we have 3 different multiplication problems, they're all tied, so we just go from left to right. 5 times 9 is 45, so we'll have 45 plus 4 times 5 times 1/2. Our next multiplication is going to be 4 times 5, which is 20, so we'll have 45 plus 20 times 1/2. And for our last multiplication, we'll have 20 times 1/2. When multiplying 20 times 1/2, we can write 20 as 20 over 1 and multiply that by 1/2, and we can see that the 2 and the 20 can cross cancel to make 10 and 1. This will just equal 10 over 1, which is equal to 10. Another way you could have thought of this is half of 20 is equal to 10, so we'll write 45 plus 10. Finding the sum of these, we have a final answer of 55. This is the value of this expression. Here's number 7. We have 10f plus 20e minus 2 divided by c. First, let's plug in the values for f, e, and c. 10f just means 10 times f, and we know f is equal to 0.3, so we have 10 times 0.3 plus 20e is 20 times e, so we're going to have 20 times 4.5 minus 2 divided by c, which is equal to 1/2. There's no grouping symbols and there's no exponent, so we need to start with either multiplication or division. Since we have both, we'll do the one that's most on the left. We'll start with this 10 times 0.3. When multiplying any decimal by 10, you can just slide the decimal over one spot to the right because it gets 10 times bigger. 10 times 0.3 is equal to 3, so we'll have 3 plus 20 times 4.5 minus 2 divided by 1/2. Now let's multiply this 20 times 4.5. Just in case you need to see it, I'm going to multiply this on the side, 20 times 4.5. 5 times 0 is 0, 5 times 2 is going to be 10. Put a placeholder, 4 times 0 is 0, and 4 times 2 is 8. And adding these together, we're going to get 0, 0, and a 9. And our decimal is going to go right here. 20 times 4.5 is equal to 90, so we'll have 3 plus 90 minus 2 divided by 1/2. Next, we're going to do this division of 2 divided by 1/2. To divide fractions, we can write this 2 as 2 over 1 divided by 1/2, and we can keep, change, flip. we can rewrite this as 2 over 1 multiplied by the reciprocal of 2 over 1. 2 times 2 on top is going to be 4, and 1 times 1 on bottom is going to be 1. This will be equal to 4. This should make sense because 1/2 fits into 2 wholes 4 times. We can write 3 plus 90 minus 4. Addition and subtraction are equally important, so I'll go from left to right. 3 plus 90 is 93, so we'll have 93 minus 4. And the difference of those two numbers is going to be 89. That's the value of this expression. Number 8. We have 18d minus 8c plus ab. First thing we're going to do is substitute in our values for d, c, a, and b. d is equal to 2/3, so we're going to have 18 times 2/3. c is equal to 1/2, so we're going to have minus 8 times 1/2. We're going to add the product of a and b. a is 3 and b is 5, so we'll have 3 times 5. We have 3 different multiplication problems, so we'll just do the one on the left first. Multiplying 18 times 2/3, 18 can be written as 18 over 1, multiplied by 2 over 3. The 3 and 18 can cross cancel to make 1 and 6, and 6 times 2 is 12, and 1 times 1 is 1. This is equal to 12 wholes. 18 times 2/3 is equal to 12 wholes, so we'll have 12 minus 8 times 1/2 plus 3 times 5. Multiplying 8 times 1/2, we can rewrite 8 as 8 over 1 multiplied by 1 over 2. The 2 and 8 will cross cancel to make 4 and 1, and 4 times 1 is equal to 4, and 1 times 1 is 1, and this simplifies down to 4 wholes. 8 times 1/2, or half of 8, is equal to 4, so we'll have 12 minus 4 plus 3 times 5. For our last multiplication, we have 3 times 5, that's equal to 15, so we'll have 12 minus 4 plus 15. Addition and subtraction are equally important, so we go from left to right. 12 minus 4 is equal to 8, so we have 8 plus 15. And the sum of 8 and 15 is equal to 23. That's the value of this expression. Number 9. We have d plus a multiplied by the quantity of c plus d divided by 4, all raised to the a power. First, we're going to substitute in our values for d, a, c, d, and a again. d is equal to 2/3 plus a, which is equal to 3, times the quantity of c, which is 1/2, plus d, which is 2/3. We still have this divided by 4. This whole thing is raised to the a power, which is equal to 3. Following the order of operations, we need to do the grouping symbol first, and inside there, we're going to have to do division before the addition. When dividing 2/3 by 4, we should rewrite 4 as 4 over 1. We're going to keep change flip here to change it into a multiplication problem, so we're going to have 2/3 times 1/4. The 2 and the 4 are going to cross cancel to make a 1 and a 2. So on the top we have 1 times 1, which is 1, and on the bottom we have 3 times 2, which is equal to 6. 2/3 divided by 4 is equal to 1/6, so we're going to have 2/3 plus 3 times the quantity of 1/2 plus 1/6, all raised to the third power. Since we have one more thing to do inside this grouping symbols, we're going to have to add this 1/2 plus 1/6. When adding fractions, we need to have a common denominator, or LCD, and we can multiply this 1/2 by 3 and 3 on top and bottom to get a common denominator of 6. 1/2 is the same thing as 3/6, and adding that on to 1/6, we're going to get a total of 4/6. Simplifying this by their GCF and dividing them both by 2, this simplifies down to 2/3. 1/2 plus 1/6 is equal to 2/3, so we'll have 2/3 plus 3 times 2/3 raised to the third power. Now that we're done with the grouping symbols, we have to solve this exponent. 2/3 raised to the third power is equal to 2 over 3 times 2 over 3 times 2 over 3. In the numerator, 2 times 2 is equal to 4, and 4 times 2 is equal to 8. And in the denominator, 3 times 3 is equal to 9, and 9 times 3 is equal to 27. 2/3 to the third power is 8 over 27, so we can write 2/3 plus 3 multiplied by 8 over 27. Between addition and multiplication here, we're going to have to multiply 3 times this 8 over 27. And to do that, we can rewrite 3 as 3 over 1 and multiply that by 8 over 27. This 3 and 27 can cross cancel to make 1 and 9. On top, we can multiply 1 times 8 to get 8, and on bottom, we can multiply 1 times 9 to get 9. 3 times 8/27 is equal to 8/9, so we're going to have 2/3 plus 8/9. Our final step is going to be adding these two fractions. To add fractions, we're going to have common denominators, so we need an LCD. Between 3 and 9, 9 is the LCD, so we can multiply 2/3 by 3 over 3. Our new fraction is going to be 6 over 9 plus 8 over 9, and since we have common denominators, we can add the numerators to get 14 over 9. 14 over 9 is the value of this expression. Number 10. We have a cubed minus 3 divided by c over b plus 2. Plugging in our values of a, c, and b, we're going to have 3 cubed minus 3 divided by 1/2 all over 5 plus 2. The top gets grouped together and the denominator gets grouped together. Rewriting this, we're going to have the quantity of 3 cubed minus 3 divided by 1/2 divided by the quantity of 5 plus 2. In the parentheses to the left, we're going to do this 3 cubed first. 3 cubed is equal to 3 times 3 times 3, and 3 times 3 is 9, and 9 times 3 is 27. So we can write the quantity of 27 minus 3 divided by 1/2. And inside the right parentheses, we can add 5 plus 2 to get 7, so we can divide this by 7. Inside the grouping symbol, we can do 3 divided by 1/2. And to divide 3 by 1/2, we can rewrite 3 as 3 over 1 divided by 1 over 2. And when dividing fractions, we need to keep change flip and write 3 over 1 times 2 over 1. On top, 3 times 2 is 6, and on bottom, 1 times 1 is 1. This is just equal to 6. 3 divided by 1/2 is equal to 6, so we can write 27 minus 6. This group is going to be divided by 7. Subtracting 6 from 27, we're going to get 21, and then write divided by 7, and the quotient of these two numbers is equal to 3. This is the value of this algebraic expression. In part 3, we're going to practice simplifying and evaluating algebraic expressions. In each of the next few problems, v will equal 3, w will equal 8, x will equal 1/3, y will equal 5/4, and z will equal 7.2. Here's number 11. We have 5v plus 3 plus 6x plus v plus 9x. While you could substitute the values in for v and x right now, it'll be a little bit more efficient if we actually combine like terms first and then plug them in later. This 5v and v, or 1v, are like terms, and we can add their coefficients together to get 6v. The 6x and 9x are like terms, and we can add their coefficients of 6 and 9 to get 15x. This 3 is a constant term, so we'll just add that on at the end here. Now that we've simplified our original expression of 5 terms down to 3 terms, we can substitute in our values of v and x here. V is equal to 3, so we have 6 times 3, plus x is equal to 1/3, so we have 15 times 1/3, and we have plus 3 at the end. Between the two multiplication problems, we'll go from left to right. 6 times 3 is equal to 18, so we'll have 18 plus 15 times 1/3, plus 3. Now let's multiply this 15 and 1/3 together. Multiplying 15 and 1/3, 15 is 15 over 1 times 1 over 3. This 3 and 15 can cross cancel to make a 5 and a 1. 5 times 1 is equal to 5, and 1 times 1 is 1, and that simplifies down to 5 wholes. 15 times 1/3, or 1/3 of 15, is equal to 5, so we'll have 18 plus 5 plus 3. Going from left to right, we'll add 18 plus 5 to get 23 plus 3, and adding 23 plus 3 together, we'll get 26. After first simplifying, then substituting in, 26 is the value of this algebraic expression. Let's try number 12. We have 4y plus w plus 4y plus w plus 4y plus w plus 4y plus w plus 4y plus w. Since it would be really tedious to plug in the values for y and w right now, let's see if we can simplify this expression a bit first. Notice this 4y plus w keeps on repeating itself a total of 5 different times. Since there's 5 groups of this 4y plus w, we can write 5 times the quantity of 4y plus w. Since we have 5 of these 4y's, or 5 times 4y, that's a total of 20y. And if we have 5 of these w's, or 5 of these 1w's, that's a total of 5w's. This is a much simpler version of our original expression. Let's substitute the values in for y and w now. Y is equal to 5/4, so we'll have 20 times 5/4 plus 5 times w, and since w is equal to 8, we'll have 5 times 8 here. We'll start with the multiplication on the left and multiply 20 times 5/4, and since 20 is 20 over 1, we can multiply that by 5 over 4, and cross-cancel the 4 and the 20 to get 5 and 1. On the top, 5 times 5 is 25, and on the bottom we have 1, and that simplifies down to 25 wholes. 20 times 5/4 is equal to 25, so we have 25 plus 5 times 8. And now multiplying this 5 and 8 together, that's going to be 40, so we'll have 25 plus 40. And adding these two together, we'll get a final answer of 65. That's the value of this algebraic expression. Number 13. We have 2z plus 12x plus 8.4 plus 4z plus 27x plus 8z plus 5. We'll start by combining our like terms of 12x and 27x to get 39x. Next, we'll combine our like terms of 2z, 4z, and 8z by adding their coefficients. 2 plus 4 is equal to 6, and 6 plus 8 is equal to 14, so we can add 14z. And finally, we'll add our constants, which are like terms of 8.4 and 5 wholes, to get 13.4. Now that we've combined like terms to simplify our expression, let's substitute in our values for x and z. X is equal to 1/3, so we have 39 times 1/3 plus 14 times z, and z is equal to 7.2, so we'll multiply that right over here, and then add on the 13.4, which is our constant. We have two multiplication problems, but we'll start with the one on the left. Multiplying 39 by 1/3, we can rewrite 39 as 39 over 1, multiplied by 1/3. The 3 and 39 are going to cross-cancel to make 1 and 13. 13 times 1 is 13, and 1 times 1 is 1, and this simplifies down to just 13 wholes. 39 times 1/3, or 1/3 of 39, is equal to 13, plus 14 times 7.2, plus 13.4. Now we're going to multiply this 14 by 7.2. They both have two digits, so it doesn't matter which one you write on top. 2 times 4 is 8, and 2 times 1 is 2. We put a placeholder. 7 times 4 is 28, carry the 2. 7 times 1 is 7, plus 2 is 9. Adding these together, we have 8, 0, carry the 1, and that's going to be a 10. We have one decimal place, so we have 100.8. 14 times 7.2 is 100.8, so we'll have 13 plus 100.8 plus 13.4. Adding from left to right, 13 plus 100.8 is 113.8 plus 13.4. Now let's add these two decimals. When adding decimals, the decimal is going to come straight down. 8 plus 4 is going to be 12, carry the 1. 1 plus 3 plus 3 is 7. 1 plus 1 is 2, and we have a 1 here. The sum of these decimals is going to be 127.2. This is the value of this algebraic expression. In part 4, we're going to take a look at the distributive property. Here's problem 14. We have the expression 24 plus 18. To rewrite this expression using the distributive property, we need to find common factors. We can use the ladder method to find that. 2 goes into 24 and 18 because they're even, and it goes into 24 12 times, and it goes into 18 9 times. And what goes into 12 and 9 is going to be 3. 3 goes into 12 4 times, and 3 goes into 9 3 times. Now that 4 and 3 are relatively prime, we can multiply 2 and 3 together to get the GCF of 6. We can rewrite 24 plus 18 using the distributive property and write 6 times the quantity of 4 plus 3. You could also rewrite the expression as 3 times the quantity of 8 plus 6, 2 times the quantity of 12 plus 9, or 1 times the quantity of 24 plus 18. While you could write it these different ways, this top one is preferred because it has the GCF on the outside and relatively prime terms on the inside. Let's try 15. We have the expression 7x plus 28. We need to think of a common factor between the terms of 7x and 28. Looking at the coefficient of 7 and the constant of 28, we can think of the number 7. 7 goes into 7x x times, and 7 goes into 28 4 times. Since x and 4 are relatively prime, our GCF is equal to 7. Using the distributive property, we can rewrite this expression as 7 times the quantity of x plus 4. This is our equivalent expression using the distributive property. Here's 16. We have the expression 20a minus 45b. Thinking of a common factor between 20a and 45b, they don't have anything in common variable-wise, but they do have something in common between their coefficients. 5 is a common factor. 5 goes into 20a 4a times, and 5 goes into 45b 9b times. We can stop here because 4 and 9 are relatively prime, and a and b are relatively prime. That means 5 is our GCF. We can write 5 times the quantity of 4a minus 9b. This is our equivalent expression. Here's 17. We have 4 times the quantity of 2h plus 5k. To rewrite this using the distributive property, we're going to first multiply this 4 times this 2h because it really means that we have 4 of these 2h's. 4 times 2h is equal to 8h, and then we have 4 of these 5k's, or 4 times 5k. That's going to equal 20k. Using the distributive property, this is our equivalent expression. Here's 18. We have 2/3 times the quantity of 18j minus 30k. First, we're going to multiply this 2/3 times 18j. And to do that, we'll write 2/3 times 18 over 1. We can cross cancel the 3 and the 18 to make 1 and 6. And 2 times 6 is 12, and 1 times 1 is 1, and that simplifies down to 12. 2/3 of 18j is equal to 12j. Distributing this 2/3 to this negative 30k, we can write 2/3 times 30 over 1. The 3 and 30 are going to cross cancel to make 1 and 10. And 2 times 10 is going to be 20, and 1 times 1 is 1, and that simplifies down to 20 wholes. So 2/3 of 30k, we can write minus 20k. This is our equivalent expression. And here's number 19. We have 2.5 times the quantity of 6m plus 10n. First, we're going to multiply this 2.5 times this 6m. Multiplying 2.5 times 6 together, the 6 times 5 is going to be 30, and carry the 3. And 6 times 2 is 12, plus 3 is 15. Put the decimal right over here, and we know that 2.5 times 6m is going to equal 15m. Then distributing this 2.5 to this 10n, we're going to have to multiply 2.5 times 10, and we know that's just going to be 25 because we can slide the decimal over, and we can write 25m. This is our equivalent algebraic expression. Here in part 5, we're going to review algebraic expressions vocabulary. Let's look at the expression 4x plus 8 plus x plus 2 plus 6x. The terms here are going to be 4x, 8, x, 2, and 6x. Of these terms, 4x, x, and 6x are like each other, and this 8 and 2 are constants and they're like each other. That being said, 8 and 2 are our constant terms because the value of these terms don't ever change. Our coefficients can be found in front of each of our variables. Here we have a 4, we have an invisible 1 in front of this x, and we have this 6. So our coefficients are going to be 4, 1, and 6. Question 21. Let's look at the expression 3a plus 8b plus 4. The terms here are going to be 3a, 8b, and 4. In terms of like terms, there are none here. These are all different types of terms. Our constant term here is just going to be 4. It's the only one without a variable. And our coefficients are the numbers in front of the variables are the 3 and the 8. For this algebraic expression, there are a total of 3 terms. Question 22. We have the expression 5 plus 4y plus 3 plus 8y plus 9. Our terms here are going to be 5, 4y, 3, 8y, and 9. Out of all these terms, 4y and 8y are like each other, and 5, 3, and 9 are like each other. Out of these 5 different terms, 3 of them don't ever change, which are the constants, 5, 3, and 9. Our coefficients are the numbers in front of each letter being multiplied, so we have 4 and we have 8. In part 6, we're going to practice translating verbal expressions to mathematical expressions, and then go from mathematical expressions back to verbal expressions. In 23, we have 9 more than triple a number x. If we have 9 more than something, that means we're going to have to add 9 onto something else. To triple something means to multiply it by 3, so we're going to multiply this variable x by 3. To write that, we can write 3x. Since it has to be 9 more than triple the number x, we have to write 3x first and write plus 9 afterwards. This is our mathematical expression for the verbal expression we were given. In number 24, we have 4 less than the quotient of a number p and 2. 4 less than means we're going to be subtracting 4 from something else. And when we find the quotient of things, that means we're going to be dividing. So we're going to be dividing 2 things here. We're going to be dividing p and 2. Since it's 4 less than that quotient, we need to find the quotient first, which is going to be p over 2, or p divided by 2, and subtract 4 afterwards. This is our mathematical expression. For number 25, let's try writing this mathematical expression as a verbal expression. We have 4 divided by 2 plus 5. We could say something like 5 more than the quotient of 4 and 2. You could also say something like the sum of the quotient of 4 and 2 and 5. Let's try 26 now, where we have 5w minus 7. Remember that 5w means 5 times w, and we're going to take away 7 afterwards. As a verbal expression, we can say something like 7 less than the product of 5 and w. While I didn't write it, you could also write something like the difference of the product of 5 and w and 7. Since difference means subtraction, we could also use those words as well. That brings us to part 7, our final set of practice problems. Each of these examples will be application word problems or geometry applications. Sawyer earns $5 for every time he does a good deed in life, and he already has $23 in his bank account. In part A, we need to use D to represent how many good deeds Sawyer does to write an algebraic expression that represents the total amount of money that Sawyer makes. We know that Sawyer already has $23, so that's constant, and then he's going to make $5 per good deed, or 5 times the number of deeds he does. This 23 plus 5d is our algebraic expression that represents the total amount of money that Sawyer makes. If d is 0, then 5 times 0 is 0, plus 23 is still $23. Even if Sawyer does 0 good deeds, he'll still have his $23. If d was 2, then 5 times 2 is 10, he gets $10 for the 2 good deeds, and add that on to 23, and that would be $33. Let's look at part B now. If Sawyer does 9 good deeds, let's write and evaluate a numerical expression to determine how much money Sawyer makes. Well, we already know that our algebraic expression is 23 plus 5d. In this case, though, we know that Sawyer does 9 good deeds, so we're going to substitute a 9 in for d. Plugging it in, we'll have 23 plus 5 times 9. Following the order of operations, 5 times 9 is going to be 45, so we have the $23 he already had, plus 45 more dollars that he made. And adding 23 and 45 together, we get a total of $68. If Sawyer does 9 good deeds, he'll have a total of $68. 23 of it he already had from the beginning, and 45 of it is new from doing good things. Let's look at part C now. If Sawyer does 74 good deeds, let's write and evaluate a numerical expression to determine how much money Sawyer makes. We'll start off with the same model, or the same algebraic expression of 23 plus 5d. And d represents the number of good deeds he does, so we're going to write 23 plus 5 times this 74. Multiplying 5 times 74, we're going to get 370, so we're going to write 23 plus 370. And adding 23 plus $373, we're going to get a total of $393. Of this $393, 23 of it he had from the beginning, and 370 he gained from doing 74 good deeds. Question 28. Marcos is buying some pencils and erasers. Pencils cost 50 cents each, and erasers cost 75 cents each. For part A, we need to use P to represent the number of pencils and E to represent the number of erasers. We need to write an algebraic expression that represents the total amount of money that Marcos spends on these supplies. Since pencils are going to cost 50 cents each, we have to write 0.50 or 0.5 multiplied by how many pencils that Marcos purchases. We can write 0.5 times p as 0.5p. To get the total, we need to add the cost of the erasers as well. Since the erasers are 75 cents each, we have to do 0.75 times the amount of erasers he buys, or the letter E. 0.75 times e, we can just write as 0.75e. This right here is our algebraic expression. 0.5 is our coefficient for p, and 0.75 is our coefficient for e. In part B, we know Marcos buys 9 pencils and 7 erasers. Let's write and evaluate a numerical expression to determine how much money he's going to spend on this stuff. So for part B here, we know our algebraic expression is going to be 0.5 or 50 cents for every pencil, plus 0.75e or 75 cents for every eraser. If he buys 9 pencils, that means that p is going to be 9, so we have 0.5 times 9. And if he buys 7 erasers, that means e is 7, so we're going to have 0.75 times 7. 9 pencils at 50 cents each, or 0.5 times 9, that's going to equal 4.5 or $4.50. And 0.75 times 7, or 7 erasers at 75 cents each, is going to be a total of $5.25. Adding the total price of the pencils together with the eraser, we're going to get a total of $9.75. This would be the total cost for the 9 pencils and 7 erasers. In part C, Marcos now buys 74 pencils and 25 erasers. Let's repeat the same process as part B, but with these different values now. We have our original expression of 0.5p plus 0.75e. It's 50 cents each, but this time we're buying 74 of these pencils, and it's 75 cents each for each of the erasers, but we're buying 25 of them this time. 74 pencils at 50 cents each is going to be a total of $37, and 25 erasers at 75 cents each is going to be a total of $18.75. Adding the cost of pencils to the cost of erasers, we're going to get a total cost of $55.75. That will be the total cost of these supplies if Marcos buys 74 pencils and 25 erasers. Question 29. Let's simplify and evaluate the algebraic expression below for each of the given values of x, and then fill in the table. You should first look at this algebraic expression and realize that it can be simplified. You should start off by distributing this 2 to this 6x and this 9, and from that you would get 4x plus 2 times 6x is 12x, and 2 times 9 is 18, plus 5 and plus x. This 4x, 12x, and 1x are like terms and can be combined. 4x plus 12x is 16x, and 16x plus the 1x is going to be 17x. And over here, this 5 and 18 are constant terms and can be combined to make a positive 23. It's going to be much easier for us to use this simplified algebraic expression. So we have our algebraic expression of 17x plus 23, and we're going to evaluate it when x is 0 first. When x is 0, we have 17 times 0 plus 23. 17 times 0 is going to be 0, so we'll have 0 plus 23. And 0 plus 23 is going to equal 23. When x is 0, the value of this algebraic expression is 23. Now let's evaluate the algebraic expression when x is equal to 1. When x is 1, we have 17 times 1 plus 23. 17 times 1 is equal to 17, so we have 17 plus 23. And 17 plus 23 is going to equal 40. When x is equal to 1, the expression is equal to 40. Now we're going to evaluate the expression when x is equal to 2. When x is 2, we have 17 times 2 plus 23. 17 times 2 is going to be 34, so we have 34 plus 23, and 34 plus 23 is going to equal 67. When x is equal to 2, the expression is equal to 67. Now let's evaluate the expression when x is equal to 6. When x is equal to 6, we'll have 17 times 6 plus 23. 17 times 6 is going to be 102, so we'll have 102 plus 23. And 102 plus 23 is going to be 125. When x is equal to 6, the value of the expression is 125. And finally, we're going to evaluate this algebraic expression when x is equal to 14. We'll have 17 times 14 plus 23. And 17 times 14 is going to be 238, so we'll have 238 plus 23. And 238 plus 23 is going to equal 261. When x is 14, the value of the expression is 261. And finally, here's question 30, the last example of this video. We're going to use this rectangle down here to answer each of the following questions. For part A, we're going to write and simplify an algebraic expression that represents the perimeter of the rectangle. Remember, the formula for the perimeter of a rectangle is P is equal to twice the length plus twice the width. We can call the length here 5x plus 3, so we have 2 of these 5x plus 3's, plus 2 of these 8's, which is the width. Here's our algebraic expression, but we need to simplify it now. 2 of these 5x's and 2 of these 3's is going to simplify down into saying we have 10x plus 6, because 2 times 5x is 10x, and 2 times 3 is equal to 6. Multiplying this 2 times 8 together, we're going to get 16. Combining these constants of 6 and 16 together, we're going to get 10x plus 22. This 10x plus 22 is our simplified algebraic expression that represents perimeter. Hopefully it makes sense why we have 2 of the 5x plus 3's, because we have it on the bottom as well as the top, and hopefully it makes sense we have 2 of the 8's because we have an 8 on the left and an 8 on the right. In part B, we need to write and simplify an algebraic expression that represents the area of the rectangle. The formula for area of a rectangle is going to be length times width. The length of this rectangle is going to be 5x plus 3, and we can call the width 8. Simplifying this, we can distribute the 8 to the 5x and 8 to the 3 here. 8 times 5x, or 8 of these 5x's, is really 40x, and 8 times 3, or 8 of these 3's, is going to be 24. 40x plus 24 is the simplified algebraic expression that represents the area of this rectangle. For part C, we need to find the perimeter of the rectangle if x is equal to 6. We already found the algebraic expression to find the perimeter in part A, and we found that the perimeter is equal to 10x plus 22. Since we now know that x is equal to 6, we can substitute it in and say 10 times 6 plus 22. 10 times 6 is equal to 60, so we can write 60 plus 22. And adding 60 plus 22 together, we're going to get a total of 82 units. If x was equal to 6, the perimeter of this rectangle would be 82 units. Finally, for part D, we're going to find the area of the rectangle if x is equal to 14. For part D, we need to find the area when x is equal to 14. We know the area here is going to be 40x plus 24, because we already found that out in part B, and we're just going to substitute in 14 for x. We'll have 40 times 14 plus 24. This 40 times 14 is going to be 560, so we'll have 560 plus 24. Adding 560 to 24, we're going to get 584 square units, or units squared. If x was equal to 14, the area of this rectangle would be 584 square units. And that wraps up this video covering 30 different questions on numerical and algebraic expressions. If you found this video helpful, please give the video a thumbs up and let me know in the comment section below. Keep up the good work, and I'll see you in the next one.